All right, series example 1. Okay, so first a little review. Let's first look at the sum. Draw this a little better here. That's not much better, is it? All right, there we go. Good enough. All right, let's see. N equals 1 to 4, 1 over n. Right, remember this is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. We can write this as 1. Okay. Okay, so I'm not going to draw this to scale. I want to have enough rectangles here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. All right, this is n. This is an. Remember that an is the formula here. Okay, so first I'm just going to draw the first few terms from 1 to 4 of the sequence an equals 1 over n. All right, so you have 1 there, then halfway, let's say that's about halfway. 2 goes up to a half. 3 goes up to a third. 4 goes up to a fourth. Okay, something like that. All right, so now I've drawn the sequence an, 1 over n, the first few terms from 1 through 4. Okay. Now I'll draw in the rectangles that make the sum. Remember, I could draw them with using right endpoints or left endpoints for the rectangles. Doesn't matter. Just shift the rectangles over. The overall area is the same. I'm going to draw them with left endpoints. Okay, so you can see that this sum represents, or this is the graphical representation of this sum. This rectangle has width 1 and height 1. So that's 1. This rectangle has width 1 and height 1/2. This rectangle has width 1 and height 1/3. This rectangle has width 1 and height 1/4. So this area is 1 plus a half plus a third plus a fourth. You see that there. Okay, now with series are infinite sums. So the upper bound is not 4. The upper bound is infinity. So then we just keep doing this. 1/5, 1/6, and on and on and on. And now the question is, can we make sense of this sum? Just like with the improper integrals, When they converge, we can make sense. When they diverge, we can't make sense. You'll see that there's a connection between these and integrals in the next few videos. This one actually diverges. And we'll see why that is in the next few videos. And all these rectangles, their sums just they just continue forever and ever, getting smaller and smaller as we go. So small you probably can't see them, but mathematically they are there. Okay. All right. So there's that. The sum from 1 to infinity of 1 over n squared. I'm just going to write out the first few terms here. As we know, this is 1. So we have 1 plus a fourth plus an eighth. Oh wait, that's not an eighth, that's a ninth, right? That's a ninth, my bad. Plus 1 16th, plus 1 25th, plus 1 36th, plus 1 49th, and continuing on and on and on. Now we will see that this actually converges. There is some number that continuing and adding just this little bit more actually narrows in on, and there's a number there. Whereas this one, surprisingly enough, doesn't actually narrow in on a number.